Will you trust AI with your life? I won't. Just kidding, that's not what we're going to talk about today. We're going to talk about how we can use, and when we can use rather, AI for our data analysis work. There's just so many kinds of data analysis. Data analysis is just not one single thing. So you can get AI to write code, you can get AI to design research experiments. So I actually found out a great Substack article. So what I'm going to say is not really just my opinion, but I really agree with it. The link to the Substack article in the description of the video. So when to trust AI for analysis? So the first important point to keep in mind is that not all data tasks are created equal. Okay, and there are certain things which fall within the go zone, and then there are certain things which fall outside it. Ad hoc analysis and EDA. Ad hoc analysis, this is where you get it to write just good old plain SQL. It's going to write hundreds and hundreds of lines of good SQL code, correct code. So the important point is that it's very well trained on the syntaxes. So it really understands the syntaxes of the different programming languages very well. It really writes code well. However, you have to guide it. So you need to be the friend, philosopher, guide, whatever, to AI. So AI is going to be your trusted companion, but it really needs guidance. So it's like a very, very good, high quality intern. That's the way you should be treating it. It can generate lots and lots of good plots. Visualization is fantastic, I'll say. And again, this is something you could have obviously done using Python. You could have used Matplotlib, you could have used Plotly, all kinds of wonderful packages are out there. There's ggplot in R, but that's going to take a longer time, right? It's going to take much longer. This is where you really leverage AI. This is the really powerful, definitely go for AI zone. If it becomes too complex, if the SQL that it has generated is too complex, ask it to explain. It will explain line by line, and sometimes what happens is it will figure out its own mistake. The zone that you should not be going into, this is what you should not be doing while using AI, and that is causal inference, advanced analytics or measurement, which are extremely conceptual in nature. It's not just about code. There's a lot of concepts, there's a lot of mathematics, and it's an overlap of different kinds of disciplines. So just to give an example, like there are so many different kinds of assumptions in causal inference. If it misses any one of those, or it misses any one of the important confounding variables, and if it does do that, and you don't even know that it has done that, and you just accept whatever output it has given uncritically, you can be in for a big shocker. So there are things like, say, SUTFA, which is stable unit treatment value assumption, extremely important assumption. This simply means that there are no spillover effects. The assumption of parallel trends, suppose for difference in differences, any assumptions related to your instrumental variables, any assumptions related to your data generating process or your DAG design, anything in your research process, in your research design, in your experimentation framework, it can absolutely lead to disaster. There are just so many moving parts, and that's why you really need to be there. So DID, do I, use the syntaxes. You don't have to write the code from scratch, but never settle for the logic being done by AI itself. So AI is a superpower when you're doing very simple ad hoc analysis or very basic EDA. To be honest though, if you ask me, like, EDA can also be a little risky to leave it to it completely. We'll actually get to it in a moment. Medium vibing, which is where A/B testing. So there are things that it can do really well. There are aspects of the packages, the syntaxes that it knows very well. Fine, you can go ahead and ask it to do that. You can even ask it to do computation of statistical calculations, like calculate standard deviation here. As long as you ask it to do it, it's probably going to do it well. And you can also define it. There should be a name of a formula or an approach to correlation. Suppose you say, specify whether it's going to be Spearman's correlation or Pearson's correlation. If you define that, usually it's going to do it right. You can always verify, and that you should be doing. So AI here acting as a co-pilot, but the no-fight zone is the causal inference zone, like advanced measurement, like causal inference. There, the AI is only for syntax reference, but not for any brainy stuff. So the brain has to be yours there. So that's the whole idea. In the AI augmented era, your value lies in your ability to separate the wheat from the chaff, to basically safeguard the truth. So the speed accuracy death trap, and this is nicely given by a graph here, and if you look at the speed accuracy death trap graph, that you actually try to increase accuracy at the expense of speed, because if the human is always involved with the tasks and is trying to cross-check each and everything, or trying to do everything manually, then of course you are possibly going to become much more accurate, but you are going to do so at the expense of speed. So we'll have to strike a balance. On the other hand, if you just rely on AI for everything, it's going to do things fast, but it's going to do things wrong. So we'll have to be very careful about this death trap, and both of these are actually problematic. And if I look at this really nice graph, you see it has divided this entire 2-axis graph between speed and accuracy into 4 quadrants, and that where we really need to be is what is marked by the green, which is the first quadrant. This is what is the AI assisted part. This is what actually needs to happen: high accuracy and high speed. Right now what is happening is high speed but low accuracy, which is why it's in the second quadrant, and absolutely what's also not going to work, which is high accuracy but very low speed, and that is human analysis, and that's in the 4th quadrant. So this is where you would have to really improvise. You have to differentiate, you have to segment, and you have to decide proactively that this is where I have to actually step back and think deeper and apply my domain knowledge. And this is not always just data science knowledge or analytics knowledge. It can also be domain knowledge that you will have to use in order to augment whatever AI is doing. So it has to be a give and take relationship, to be honest. That's always a sign of a healthy relationship anyway, right? So yeah, now actually let's come to a very concrete example. So this is the diff in diff near miss example, which means that a difference in difference model was actually prepared using AI, but where the user actually did not go far enough in guiding it properly. So here, first of all, the exploratory phase of an unfamiliar domain was analyzed, and then in the next step, the user actually directs the AI to build a DID model, and then the AI goes on to write code. It knows the syntaxes from the different libraries and packages, of course. It runs regressions, it produces very interesting insights, very familiar looking graphs as well. It gets all the familiar and the usual suspects in terms of the metrics, accuracy metrics, but it fails to verify the most important parallel trends assumption. And this is why it's so dangerous. If it fails to verify those very basic fundamental assumptions, then the whole exercise becomes pointless. So the math was executed perfectly, the foundational assumption was mathematically invalid, and therefore it's your role as a principal investigator to actually catch it before you actually accept the output as is in its face value. And this is, by the way, a Substack series. This is not just one article, and it goes on to define a taxonomy of failures. And I think it's really about business context. I think that's the biggest failure, but there are a few other areas where it can actually fail miserably. AI can fail miserably when you are using it for data analysis. So missing business context is right up there. High frequency, it happens very much, and also very high severity, critical severity. Data prep hallucinations, it hasn't prepared the data, but it thinks it has, like for instance, transforming timestamps, getting the data types in the correct format. So again, keeps on happening. Severity also remains fairly high. Assumption blindness, extremely severely critical. The frequency also keeps happening fairly frequently. It's pretty medium frequency. Omitted variable bias, extremely critical. Severity is very high. Frequency is again medium. So there are these different kinds of things, and you need to be aware of these of the taxonomy of these failures. And these failures are silent failures. That's the important point, because what's happening is that everything will look convincing. See, an app failing, if it fails, if it doesn't load properly, then it's fine. Then it means that you can see it, and you can palpably understand that it's not working, but it can silently fail. Like, it might look like you have got the right results, but actually the results are not right. So that is the problem of AI at times, very often, in fact, especially as you go into advanced analysis. So the the key takeaway here is just that your value is really in your ability to safeguard the truth. And the more you can actually do that, the better will be your position. So the argument here is not that you don't use AI, but the argument is really that you use AI in the right way, in the ways that it's really going to be useful for, and not for asking it to do things where the human brain is extremely crucial. So if you ask it to take decisions about experiments, about causal inference, about advanced measurement, then of course you are in for a bad experience. You will get cases where you are basically accepting very poor outputs which look great on paper, but they are absurd, or they are simply plain and simple wrong. Not just seasoned data scientists, but definitely even marketing analysts who are really starting to play around with a lot of data science kind of stuff through AI tools. I think they would really find it very important, because they must be wondering at times that, hey, I don't really know the theory, but it's giving me the output and it looks right, but should I be able to trust it? Should I be trusting it? So here's your answer to that question. Hope this was useful. Again, always I'm completely open for having very nice discussions. So if you have any questions, any rejoinders, do let me know in the comments, and I'll see you in the next one. Thank you.